Hello students, the topic which I am going to deal with is photochemistry. We are familiar with photosynthesis taking place in plants where carbon dioxide and water reacts to give glucose and molecular oxygen. The reaction takes place by the absorption of light by the chlorophyll pigments present in leaf. Vitamin D, which is essential for the normal growth of bones and teeth, it is synthesized in our body on exposure of skin to the light. We can see the beautiful world because of the photochemical reaction taking place in our eyes. A molecule called retinol isomerizes to form a double bond and absorption of light. So what is a photochemical reaction? A reaction which takes place on the absorption of IR, UV or visible radiation is called photochemical reaction. And photochemistry is a branch which deals with the study of chemical reactions taking place by the absorption of light. So the reaction takes place between 800 to 200 nanometer. On the other hand, we have ordinary chemical reaction taking place in the absence of light but by the absorption of heat. So these reactions are called thermal reactions and also called dark reactions because they takes place in the absence of light. There are differences between photochemical and thermal reactions. As I've already said, photochemical reactions takes place in the presence of light, whereas thermal reactions takes place in the absence of light. The change in free energy in case of photochemical reactions may be negative or positive, whereas in case of thermal reaction it is always negative. There is selectivity of a molecule in a photochemical reaction. For example, if we want to excite one particular atom or one particular molecule, we can supply certain wavelengths of light and we get a result where one molecule or one atom is excited, whereas in case of thermal reactions all the molecules are excited at once. So the important criteria for a photochemical reaction to happen is the relevant photon should be able to cause excitation of molecule from ground state to excited state, which essentially involves jumping of electron from bonding molecular orbital to antibonding molecular orbital. So what is the interaction of electron or radiations with matter? First of all, the matter absorbs light, which is called photoprocess or primary process. All other processes occurring after primary process is called secondary process. So after primary process, that is after absorption of light, the molecule undergoes excitation. So after excitation, the electron can get ejected, which is also called photoelectric effect, which happens in case of metals, or they may get jumped to higher energy levels. After they jump to higher energy levels, there are three possible fate for an electron. Either it can undergo fluorescence or phosphorescence or chemical reaction. Certain substances, when exposed to light or radiations, they absorb radiations or energy and they re-emit the absorbed energy. So immediately, if the process takes place instantaneously, they are called fluorescence or fluorescent substances. Example is fluorescent or eosin. There are certain other substances where they emit the absorbed radiation after some time, or it is a slow fluorescence. They are called phosphorescent substances. Example is zinc sulfide or alkaline earth sulfides. So next, there is laws of photochemistry. There are two laws of photochemistry. First one is Stark-Einstein's law and the second one is Grother-Draper's law. Grother-Draper law is also called first law of photochemistry or principle of photochemical activation. So this was discovered by two scientists, Grother and Draper, in 19th century. The law states that only that light which is absorbed by a system can bring about a photochemical reaction. Second law is Stark-Einstein's law or principle of quantum activation. This was enunciated by scientists called Stark in 1908 and independently by Einstein in 1912. The law states that one molecule is activated by the absorption of one quantum of radiations. So this principle makes use of, it applies quantum of radiations to photochemistry. Quantum of radiations to photochemistry. If E is equal to NaHc by lambda, where E is Einstein's of radiation, Na is Avogadro number, H is Planck's constant and lambda is wavelength. We can see that Einstein's of radiation or energy of radiations is inversely proportional to wavelength. If wavelength absorbed is more, energy required is less. So next is Jablonski's diagram. So Jablonski's diagram is a diagram illustrating the fate of excited electrons. So the electron, if A is a molecule, if it absorbs a quantum of radiation h nu, after it gets excited, it is represented as A star. So the molecule in the excited state cannot remain in that state for long time because of the instability. Molecules are more stable in their ground state. So the molecule in the excited state, it can undergo either non-radiative process or radiative process or chemical reactions. Non-radiative process, it is a radiation-less process. If we consider S0 as a ground state, that is, if S0 is a ground state and S1 is a first singlet state, S2 is a second singlet state, and S3 is a first singlet state, and T1 has to be a first triplet state, T2 is a second triplet state, and T3 is a third triplet state. After absorption of light, the electron excites to either S1, S2 or S3, or T1, T2 or T3. So after absorption, the electron jumps to the, as I've said earlier, it jumps to the ground state. So non-radiative process, the electron jumps from S3 to S2 or S2 to S1, that is from higher excited state to slower first excited state. It can also be a triplet state too. So there are two transitions in case of non-radiative process. So internal conversion, where the electron transfers from first singlet state, third triplet state to first singlet state, that is S3 to S2, S2 to S1, or T3 to T2, T2 to T1. Or in case of internal conversion, the electron shifts from S3 to T3 or S2 to T2. So there is change in spin state. So internal conversion is a forbidden transition and it takes place very slowly. Whereas in case of radiative transitions, the electrons jumps from first singlet state to ground state, that is from S1 to S0 or from T3 to S0. So from S1 to S0, if it takes place, it is called fluorescence. So it takes place immediately. From T3 to S0, if it takes place, it requires a change in spin state and it is phosphorescence. So chemical reaction is always favored by a triplet state. From triplet state to ground state, when the electron undergo transition, it gets ample time to undergo transition. So it favors chemical reaction. That's all about laws of photochemistry, for introduction to photochemistry and Jablonski diagram. Thank you.